Okay, this is a continuation of Module 1, Lesson 2. Using dimensional analysis to convert and compare rates. So during a cycling event for charity, Amanda traveled 105 kilometers in 4.2 hours. And Brenda traveled at a rate of 0.2 miles per minute. So which girl traveled at a greater rate? And they said to use 1 mile is equal to 1.61 kilometers. So the problem with comparing Amanda and Brenda right now is it's kind of like you're comparing apples to oranges because their speeds are not in the same units. So here we go. We're going to convert Amanda's rate to the same unit as Brenda's rate. Or we could have, conversely, converted Brenda's rate to the same rate as Amanda's rate. It really doesn't make any difference. Personally, I would have done kilometers per hour, but that's just me. Okay, so however many miles per minute, you've got 105 kilometers in 4.2 hours. And you're doing the little, y'all remember my little, thing? It looks like a little bar. Okay. And you're going to say 1.61 kilometers is equivalent to 1 mile. The kilometers are catty corners, so they'll cancel. And then over here, catty corner also cancels this way. I have 4.2 hours down here, and I have 1 hour up here when I do the 60 minutes is 1 mile. So hours are catty corner also. And if you notice on top, I have 105 times 1 mile, so 105 miles. On bottom, I have 4.2 times 1.61 times 60 minutes. And when I plug and chug and get all of that done, it's 0.2588 miles per minute. So she's traveling about 0.26 miles a minute. Okay. And now that they're in the same units, 0.26 miles per minute for Amanda, 0.2 miles per minute for Brenda, so Amanda is traveling faster. But you can't really compare them until they're both in the same units. All right, a box of books has a mass of 4.10 kilograms for every meter. So 4.1 kilograms per meter is going to look like this down here. A box of magazines has a mass of 3 pounds for every foot. Which box has a greater mass per unit of height? Use 1 pound is 0.45 kilograms and 1 meter is 3.28 feet, and round your answers to the nearest tenth. So again, you're doing something similar to what you did with the Brenda and Amanda problem. Start off with 4.10 kilograms per 1 meter and start converting. Catty corner is canceling, so 0.45 kilograms is 1 pound. Set it up that way so that the kilograms will cancel. Then I'm going to use this one. In 1 meter, there are 3.28 feet. And again, it'll still cancel even though this one's over here on top and this one's over on bottom. So I get 4.10 times 1 pound. So that's 4.10 pounds. 1 times 0.45 times 3.28. 1 times 0.45 times 3.28. Grab a calculator. Your batteries are low. Okay, so 4.10 divided by, put these in parentheses, 1 times 0.4. Oops. Quit. Hang on. Try that again. 4.10 divided by, open your parentheses. Well, 1 times 0.45 is just 0.45 times 3.28. Close my parentheses. Enter. And I get 2.77. Oh, y'all can't really see that. 2.777. Anyway. Okay. 2.78 pounds per foot. So 2.78 pounds per foot for the box of magazines. 4.10 kilograms pounds. Let's see. Oh, a box of magazines has 3 pounds for every foot, and we converted the books, and the books are 2.78 pounds per foot. So the box of magazines has a greater mass per unit of height. Oops. Okay, so just looking at number 7, reflecting a little bit. Why is it important to convert rates to the same units before comparing them? Well, if you don't put them in the same unit, it's kind of like comparing apples and oranges. They're two different things. So when you're comparing rates that are in the same units, the numbers can be easily compared to see which number is greater. If the rates being compared are not in the same units, then an incorrect comparison can be made. Okay. All right, at this point, let's go to page 19. Okay, so we're still using unit rates and proportions to solve real-world problems. So here's another one. This time we are actually graphing a proportional relationship. It walks us through example 4a. Simon sold candles to raise money for a school dance. He raised a total of $25 for selling 10 candles. Find the unit rate, which is the amount earned per candle. Then graph the relationship. So amount earned, 25, divided by candles sold, 10. So x over 1 is the rate, 25 over 10, and x obviously has to be 2.5. So the unit rate is $2.50 per candle. Using this information, create scales on the x and y axis. All right, so I'm going to do whole numbers down here because I'm not going to sell half a candle. 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 10. And I know that for each candle, I make $2.50. So for one candle, it's $2.50. For 2 candles, it's $5, etc. Okay? So the x-axis will represent the candles sold, since it's the independent variable. The independent variable determines the other variable. So the number of candles sold determines how much money you make. So the amount of money you make is on the y-axis. Okay? The origin of your graph represents what happens when Simon sells no candles. Okay? And so that's your situation with that one. Let's try a similar situation down here. It says a local store sells 8 corn muffins for a total of $6. Find the unit rate. Okay, the amount earned is $6, and that is when you sell 8 muffins. So 6 divided by 8 is the same thing as x over 1, or x. And that is 0.75 or 3/4. So the unit rate is 75 cents a muffin. Again, it makes sense down at the bottom to use whole numbers because you're unlikely to sell a part of a muffin. 1, 2, 3, 4, 5, 6, 7, 8 muffins. The amount of money that you make, I'm just going to go 1, 2, 3, 4, 5, 6. So over here is the money that you make. Down here is the number of muffins. Number of muffins. If I sell 0 muffins, I make no money, so that's an easy point. And it says up here that if I sell 8 muffins, I make $6. So I put that there. If I sell 4 muffins, I make $3. So that's another easy point. 4 and 3. And you get a graph that looks like that. The x-axis is going to represent the number of muffins. The y-axis will represent the money that you make. The origin represents what happens if you sell no muffins. For this particular situation, we're going to go from 0 to 8. On the y-axis for money, 0 to 6.